Hello everybody, so I was back with another one of those Python modules that I think will just be useful. I found it to be incredibly useful over the years because it's one of my favorite things to do with electronics and computer stuff. But in our modern world, this one will especially be useful. I think it should probably already be included in classrooms. You may have heard the concept of IoT. I have my camera pulled up. Wanted to see this, and I've found that I wasn't able to switch back and forth between the embedded video and just a regular screencast, and needed some video for the first part. Oh, if I click the barcode here, there we go. That gets rid of the little blue box. So in our modern world, you've probably heard of IoT, Internet of Things, connecting all of our stuff that's not computers to our computers, so we get networking capabilities, such as I just got a new two new window unit air conditioners this summer, and connecting the air conditioners to the Wi-Fi was not optional. The new air conditioners, even cheap window units from Home Depot, automatically connect to your Wi-Fi when you plug them up. So things like that, the Internet of Things sort of stuff is definitely going to show up if you're heading into software development these days. But academia moves slow, so it hasn't really shown up in class curriculums yet. So I wanted to make sure and include at least one. So I have a little example here. That's why I had the video. So this is a little project I've been working on. Got a mouse, couple buttons, a little joystick, and a couple buttons, and a scroll wheel. So it simulates a mouse. Also radio frequency antennas. Those might be hard to see. And right now it's an Arduino, but after the testing's done with the nice, easy to use Arduino library and Python code on the computer side, I'll switch that over to I'll get rid of the Arduino bootloader and just tell the chip it's just a chip and put a much faster clock on it, and then switch the easy to use but slow Python library stuff over to an HID report. So then it's just a plug and play device that will operate as quickly as the electronics do. So, but that stuff's really, really hard to debug. The Arduino library and Python code is really, really easy to debug and get the logic together before working with those complicated versions. So that's one where I use this one a lot, because one of my favorite hobbies or pastimes is to create, try to invent new input devices, paintbrushes that wave around in the air to control graphics software, or in this case, the reason this one has radio frequency or walkie-talkie signal instead of one of the normal USBs or something, is this is going to go on a wristband, so that I have mouse control on a little wristband, so that when I'm like giving lectures in class, I can control the mouse from wherever I'm standing in the room. Usually the computer is not right next to the whiteboard, and I found that radio frequency worked best in that situation because then it doesn't interfere with whatever I may be showing in class. But this stuff comes down a serial line. And most of our communication does. We have serial communication or parallel communication. And parallel communication is a lot easier to do like on the motherboard, where it's on the PCB and we just have lots of lines running through a PCB. When we're plugging things up, it's a whole lot easier to plug in one wire. So most of our peripheral stuff, external devices, are going to run through serial communication. So with IoT having such a big place in the world, we probably are going to want some of our applications to process that serial data as it comes, things coming down the USB port or across radio frequencies or through Bluetooth channels or Wi-Fi channels. There's a whole lot of serial communication coming in, and we might need that in some of our applications. But there's a Python library to work with that stuff. So I'll go ahead and close out of the video and go over and let's look at this module for controlling bringing serial port communication into our Python application or Python script. So to start with, here's the Arduino code currently running the driver, and yeah, easy to work with, kind of like Python, so it makes debugging a lot easier. And then I can move over to the port manipulation style of programming, so that and get the absolute top speed out of the chip after the logic is together. So, yeah, it's already plugged up, so I'll just pull up the serial monitor here. So what's going on is, well, you can see right now there's a bunch of zeros. So if I was to push the black button on here, we get a 1 when the button's pushed. Or the white button. So there's the left and right clicks. I can move the mouse around, or not the mouse, sorry, move the joystick around and get different values that would control a mouse. Use those values to move the mouse around. Turn my little wheel to see how far to cover scrolling. And then with this particular device, I'll have mouse controls on like a little wrist band so that I can walk around the classroom and do things. And it's coming down a serial port, so here in the testing environment, the monitoring the serial port works good, but probably want that going to a better a more interesting application than just something printing out the numbers. Though for our example, all we're going to do is print out the numbers. But let's jump over to Python and look at how that's going to work. Obviously, the first thing we want to do is import the libraries. So I'll just come over to PowerShell, do that, and Python and the pip module, and do our normal install. And you want to be careful here because there is a library called serial, which some things will have by default. So if you're, say, running WSL, Windows Subsystems for Linux, that uses the serial library, not the one we actually want here. So make sure you run shutdown on the Windows subsystem, so the serial library doesn't show up immediately. But for us, Python, the pip module, install, we want to install pyserial. And I'm stressing this because when we import it, we import serial. So install the pyserial module, which should already be satisfied on my computer here. Yeah, already satisfied, but you'll see all the meters running and stuff. And like in the last video, if you want to put those meters in the terminal outputs, TQDM is the one module you want to install to do that. And it only has a few functions, so it's really easy to read through the documentation on that one. So that gets that installed, and I'll go over to Atom and work in this. So Atom and do something called commline.py. It's a good name for it. We'll open up our text file here, and obviously the first thing we want to do is import install pyserial and import serial. And well, then we can just do some stuff with this library. So say com will be the instance of our object from that serial module, and it is called serial. And then there's two parameters we have to fill, which I can get from the Arduino testing script. The first one is the COM port that we're connected to. So I can see over here in this IDE, I'm connected to COM3. Another place to get that is if you go to Device Manager, which one is it? M, and expand ports, you'll see the things plugged into the USB ports. This one's on COM3, and if there's a bunch and you're not sure, just unplug the one you're not sure about to see which one goes away. Is sort of the easiest way to test that. We also need to know the baud rate. You'll have probably seen pictures of waves or the sine wave going down our electrical signal. It goes up and down and up and down. And we measure that in frequency, and each wave that passes has the up part and the down part. But that's two oscillations. We have the up oscillation and down oscillation. And with inside of that wave, we can wiggle that around a little bit more. So for each one of those oscillations, up oscillation, down oscillation, we can add some more oscillations inside there to hide lots of bits. Getting into some electrical stuff there. But the traditional metric unit for oscillations is baud. It's named after somebody. I just wanted to mention that because a lot of people think that stands for something with computers, but it's a traditional metric unit. for oscillations, and each wave, the up and down, will have the up oscillation and down oscillation. So there's 2 oscillations per wave. So we need to know those 2 numbers. So we're connected on COM3, which will be different for the device, and in a lot of situations you'll eventually want to do the more complicated things to automate figuring out which port it is. But for our example, we just need to know what port it is, and we need to know the baud rate. How fast is things coming down that port? And then we can read what's going on there. And I'm just going to do it in an infinite loop. So I'll set a variable called finish to false, and then while not finished, which is essentially saying while true. But I like to do it this way so that at some point we can actually change that to true and have a graceful exit from the infinite loop. So while true or while not false, just setting up an infinite loop. I'll grab something called state, which is what's coming down the com line. So com.readLine. And for the simple example here, I guess I'll just print that out. Print out the state and just keep running through that infinite loop. So I'll finish that. Should be good to just run it here. So on Atom, turn on the platform IDE or platform IO package, and then you can just do Control-Tick to get to your PowerShell. And then we'll start the Python interpreter and have it run commline. Oh, wait. Yeah, Python interpreter and have it run commline.py script. And there we can see the binary string. Putting a B out front gives us a Unicode string in Python. Carriage return, line feed at the end. That's just how I set up the code. Right now it's all zeros, but if I push this button, is this not scrolling? Oh, everything froze up on me. Let me try it over here in PowerShell. Let me go to the actual PowerShell and run that. Python -m, oh, not module, Python interpreter, then run commline.py, and there we go. Now it's not frozen up. I can see it's moving past, so when I push the buttons, push both buttons, turn the wheel, getting all those numbers, move the joystick around. So you can see that's just reading that string that was sent down the serial communication port. In this case, a USB port. Cancel out of that, come back over. And then once you have the string, you can just process all sorts of stuff like that device I showed. If I put Windows E, go to Explorer, and in here, so there's the transmitter. That's the one we just looked at. And then I was using radio frequency, so obviously there's a receiver. And that receiver sends stuff down, sends this, so the serial communication goes across the radio frequency, where it's received as serial communication by the receiver end of the that radio walkie-talkie frequency. Most people are probably more familiar with that than if I say radio frequency. So go across the walkie-talkie line, and then that sends it to a computer where currently still in the testing phase. It opens with this. Bring that in. There's that other module that I included in the earlier video, so that once it gets in, it moves the mouse around. Just brings that in, and then it's just a matter of parsing through it. And I just did it straight as an array because that's how the HID report is going to have to be written anyway, so to help debug the logic. So we just parse through that string, split it up on the B's and the commas, and then grab each little element from there. So really easy to parse through that string and pull the data of what the device is. So that sort of stuff, the pyserial module, so that we can grab things coming through serial communication lines. such as Bluetooth and USB, will probably be very, very useful in your future as software developers, especially with IoT becoming so popular in our modern world. In fact, I think this one should probably be included in classrooms already because IoT is already so prevalent, but academia moves slow sometimes. So it will be soon. So that's the other one I wanted to share today that made the other video go long. So you can see down there 15 minutes and the other video was 10 minutes. So kind of a long video, split ended up probably worked better. This one will be an immensely useful library for you. And the big thing to remember is when you go to install it, pip install, make sure you install pyserial, because there is also a serial, if I can spell it right, S-E-R-I-A-L. Pyserial is the one we just went over here. There's also a serial library which does other stuff. So pyserial, and then we can just grab whatever data comes down the USB line, and Python comline.py, and you can see it comes in as a Unicode string with whatever line feed return you programmed into it. So then you just parse through the string coming down the comm line, and do stuff in your actual user application with whatever's plugged up to the device. That one will be immensely useful for you, so I wanted to share it. Same parting notes as the last video. Please remember the semester ends tomorrow, 11:59 p.m. Eastern Time. Make sure I get everything by then. Otherwise, if you have any questions, let me know. I am just sitting around all weekend waiting for questions to come in. And y'all have a great break.